In the land of software development, DORA has become increasingly popular over the past few years. And then I don't mean that DORA, but this DORA, which has gained a following for its performance metrics. I'm here in the R&D labs of CoolProfs, the Dutch-based OutSystems Plus expert and premier OutSystems partner, to answer the question, just what is DORA? And also to talk about DORA's latest edition, the DORA Core Model. So let's get started. DORA stands for DevOps Research and Assessment, and is an initiative founded in 2014 by 3 software experts, Nicole Forsgren, Jez Humble and Gene Kim. And you might already know Jez and Gene from books such as the Phoenix Project and the DevOps Handbook. For 3 years they conducted research with the aim of identifying practices and capabilities essential for accelerating software development within organizations. This emerged from the understanding that, as software is at the center of nearly all organizations nowadays, that in order to stay competitive we have to speed up the development process. Business as usual just no longer cuts it nowadays. Within the research, they administered some 23,000 surveys across more than 2,000 companies of various sizes, sectors, and maturity levels, and then processed this data using scientific research methods. And their efforts resulted in 2 outcomes. First of all, DORA itself, and secondly, this book, Accelerate, which provides a comprehensive account of their research, of their findings, and of their research methods. It really is worth a read. After being acquired by Google in 2018, they not only expanded the team, but they've continued their research using data from the yearly State of DevOps survey, which you can fill in as well every year. And every year they publish the State of DevOps report, which has their latest findings based on the latest data. Which brings us to the DORA Core Model, which is a distillation of their latest findings combined into a model with technical capabilities, with metrics, and with outcomes. And these are the things their research has surfaced. In gray we have capabilities, in green we have the performance metrics, and in blue the outcomes. The gray arrows between the concepts indicate predictive relationship. In short, having these capabilities in good order predicts scoring well on the performance metrics, which in turn predicts both good commercial and non-commercial outcomes. And in total 17 of these capabilities have been identified, so let's briefly get into them. First, at the heart of good software development, they have identified flexible infrastructure and proper documentation quality. Then we have 11 technical capabilities ranging from code maintainability to deployment and test automation to monitoring, observability, and trunk-based development. These technical capabilities in turn predict being able to shift left on security and of continuous software delivery. Pair this with generative organizational culture and streamlined change approval, and your software delivery will be outstanding. This video will be far too long to cover each in detail, but luckily Core provides an easy entry point as each capability is linked to an article on the website. And luckily for you OutSystems users out there, OutSystems already covers some of those capabilities. However, to cover them all, CoolProfs has created great software within their SDLC suite of products to cover the remaining capabilities of the DORA Core Model. Get in touch to know more about these vital products. Which brings us to what DORA is probably best known for, the metrics. Now, the research has surfaced 4 metrics which most accurately predict the value a team will add to an organization, which is also why they are known as the 4 key metrics. And for each metric they have identified 3 groups: low performer, medium performer, and high performer. Let's start with deployment frequency, which is how often does your organization push new versions to production or release it to end users. Here a low performer deploys between once a month and once per 6 months, and a high performer deploys multiple times a day. And achieving high deployment frequency really requires those technical capabilities, such as automated testing, automated deployment, and trunk-based development. And the key with high deployment frequency is to reduce the amount of changes you bring with each version to production, which in turn allows a team to better understand what those changes have been, which then reduces the risk of those changes going wrong. Next up is change lead time, which is the time from when a developer starts working on a new piece of code until that code is actually running in production successfully. Here for a low performer, the lead time is between 1 and 6 months, and for a high performer, between 1 day and 1 week. Change lead time can be divided up into multiple time spans. For instance, a developer might start working on a piece of code and have that code finished, but if it then takes a long time for a new version to hit production, you still will have a slow change lead time. So it ties in with deployment frequency as well. And change lead time is really important as it effectively tells you how fast your response time is. And organizations really need to respond quickly to, say, changes in the market, or changing regulations, or addressing potential risks. So it really is a vital key metric. Next up is the change failure rate, which is what is the percentage of changes you've made actually result in a degraded service, say a service outage, and then also require fixing, say a hotfix or a rollback or a patch. And this also ties in with the deployment frequency we've just discussed. As the amount of changes you make per production reduces, it also makes it easier to fix what you have changed. So your change failure rate should also go down. Here, for a low performer, that's 46 to 60% of changes result in a failure, whereas for a high performer, that's only 0 to 15%. And finally, time to restore service. Say something has gone wrong. How long does it take your team to fix that, to restore the service? And in this case, for a low performer, that's between 1 week and 1 month. And for a high performer, less than a day. This can also be divided up into multiple time spans. First of all, you have the detection process. How long does it even take you to detect that something has gone wrong? Here, having a good monitoring solution is crucial. And then, how quickly can a new change be shipped out? And this ties in with the deployment frequency and the change lead time. For OutSystems, CoolProfs has made software for the OutSystems platform to monitor team performance for those 4 key metrics, with clear and easy to stand visualizations in CoolMonitor, so that not only you can compare team performance, but also see trends over time for team performance. Get in touch about that. Now this all sounds great, but why would you want to use the DORA core model and its metrics? Well, the model stems from well-grounded scientific research spanning nearly a decade, and while there are lots of other models floating around in the software development world, DORA is the longest-running research of its kind. And secondly, the power of this model is also that it keeps evolving over time. As new data is added each year, the model is adjusted, so it always reflects the current situation of the market. And lastly, the research has shown that these capabilities and these metrics, they not only predict commercial but also non-commercial performance. So not only will your company or your organization run better, but the well-being of its developers will also improve. So it really is a win-win situation. So get going, use DORA to your advantage. And for you OutSystems users, get in touch with CoolProfs. We'd love to hear from you. So that was all for now, and as always, thanks for watching.